On the very back page, you will see number 17 and 18. Okay, they are the hardest problems for you to do on here. They're also the hardest problems for you to review, and I apologize for that. It's just how hard material works sometimes. Okay, they're the hardest for you to review because there's an infinite amount of correct answers here. That doesn't mean everything you throw up here is going to stick to the wall. It's not all going to be perfect, but there are so many correct answers that it's tough to go through them all. My first piece of advice, guys, and I told you this the day we were doing this on Monday, I said, hey, you've got to be able to read through here and pick out the most important words or what gives it away. And by give it away, I mean what function family? Linear, exponential, or quadratic. There's 3 of them. We know the graph of linears are straight lines. Our graph of exponentials are our elbows. Guys, it's the second time I've done this. This might be something important to know. Guys, second time I put this on the review. Drawing this up here. We know that linears are y equals mx plus b. We know that our exponentials are y equals abx, but really the important part, guys, there is this little raised to an x power. And then finally, our quadratic has this really long equation, okay? It's got all sorts of different extra pieces it can and can't have in it. But the important part, and what we've kind of summarized it to, is that the base root of it is that it needs to have an x raised to a variable of 2, squared in other words. Okay, we'll get into those in much greater detail. In fact, we have chapters on each of them, especially quadratic. We do a lot of work with quadratics. But for now, we realize the root of a quadratic is just that it has an x squared. That's kind of the super important part. Not the only important part, but like the real, that's what makes quadratics quadratics, in other words. Well, we're reading down through this list. Function, that could be any of those things. Continuous, that could be any of those, as long as I don't do discrete dotted lines. Exponential right there. That's really where I know I'm going to start. Okay. And then finally, the only one we're going to have to really worry about on this one, we're going to have to toy with it until it's decreasing. Guys, hop in the calculator. Okay. We know our most basic exponential function is just 2 raised to the x power. I start there by graphing it. Is it a function? Yes. Is it continuous? Yes. Remember, we only do continuous on the actual graphing calculator. We do a little bit of something that could be considered discrete when we get into stats, but that's for a different time. Exponential. Yes, it's an elbow, but decreasing. No, it is not. Okay. Now you can go in here and you can start toying around. You can start just like, oh, maybe adding 2, or actually we want it to be decreasing. Maybe subtract 2. Maybe that changes it, Mr. Sorrell. Maybe that flips it around. No. That's still increasing. My advice, whenever you change something and it doesn't work, go back and delete that. Otherwise, you're going to end up with a slew of changes and you're not going to know which one actually did the right thing. What I'm going to do is I'm going to insert a negative sign out front. Now, again, if you want to just delete it and retype the whole thing, that's fine. But remember, general rule of thumb, to flip something upside down, throw a negative out front. Okay? That's not always going to work for the rest of your life. But in Algebra 1, it stays fairly consistent. Negative signs tend to flip things, okay? Now when we graph it, we see it continues along the x-axis, and then it decreases. Is it a function? Once I think I've got it, I go back over my checklist. Is it a function? Yes. Is it continuous? Yes. Exponential? Yes. And now it is decreasing. And now comes the moment of truth. You have to graph this and write the corresponding equation down. It cannot be a random graph and a random equation. I don't know how many people on their homework from today gave me a great graph that obviously they had in their calculator, okay? But then they gave me a random equation like y equals 2x plus 3. That has nothing to do with that. It's not even close, okay? It has to be a corresponding equation. F of x in this case equals -2 raised to the x power. Speaking of things I saw on homework all the time, and in fact, I really should, my graph should be a little bit better. It should go through this point right here. Well, this is turning into a travesty of a graph. Not an artist. There we go, that's a little bit better. Okay? I can't tell you how many people on the homework, okay? How many people on the homework gave me this graph? They said, oh, mine looks the same, Mr. Sorrell. It's flattened off in an area, and then it goes down. And I just kept telling them, I was like, guys, this is not the same graph. You've got it crossing here and here. The correct graph's only supposed to cross once right there. How are you going to tell me it's the same graph? Please be careful with your graphs, guys. You know I'm not a huge stickler for, sketching a graph accurately, but if it's supposed to cross at a certain point, make sure it crosses there. That's why we did X and Y intercepts. We spent a whole day doing stuff like that, so that when it came time to sketch these graphs, you knew what the important points were. Finally, down to number 18. Guys, whichever one, number 17 or 18 tomorrow, has discrete, I'd probably call it the hardest problem on there. Probably the hardest problem on the test. Now, some of you are great at these, okay? But discrete is difficult to do. I need it to be a function. That's any of those. I need to be discrete. Any of them can be discrete. I need it to have a minimum. Quietly, guys, that's our giveaway that we're looking for quadratic, which means x squared. Minimum. A minimum means it has to be x squared, because the only function family we've talked about so far with a lowest or highest point is quadratics. And then finally, the one we're going to have to play with a little bit, don't pass through the origin. Okay? Well, let's start with our most basic quadratic graph, x squared. We hit graph. Is it a function? Yep. Is it discrete? No, but we can't really do that on the calculator. We can't make the calculator show us discrete. Does it have a minimum? Yes, it does. It does not pass through the origin. Uh-oh, ours does. So now when you start playing with it, you say, well, Mr. Sorrell, last time we were messing with an equation, we just inserted a negative sign out front, and that fixed our whole world. Well, in this case, that's not going to help. One, it still goes through the origin. Two, we've screwed it up even more. It's got a maximum now. We want that minimum. Okay? So we get rid of that. We go back to square one. The actual solution here. Some people have tried putting numbers out front. All it does is make it skinnier or fatter. The actual solution here is to put a number out at the very end. I'm going to choose, -3. I've been using lots of 2s and 3s today. -3. Now I look at my graph. Still a parabola. Still has a minimum. Does not go through the origin anymore. And now I would graph that. Okay, now I would try to put that in discrete form. So one way you can do discrete form, you can start just by putting a dot you can see, for example, 0, -3. And then you can try to eyeball it and be like, well, where's the next point going to be? I'm going to show you the shortcut. The shortcut, again, is to do second graph. So we're right back there at that graph button, but this time we press second first. Second graph. And it brings up a table. Since you have a calculator in one hand and your pencil in the other, it's very easy for you to just read from that table. We're going to have 1, -2, 2, 1, and 3, 6. So 1, -2 is going to be right there. Okay. 2, 1 is going to be right here. And 3, 1, 2, 3, 4, 5, 3, 6 is going to be up there, just off the screen a little bit. And because it's a parabola, we saw that it's going to mirror. You can also check that by scrolling up in your table. To scroll up and down your table, again, you use the arrow key. And now we have our parabola that is discrete. Please, at the end of the day, once you're done, please don't do this. That kind of ruins the whole point of discrete, guys. Don't connect the dots. This is not being a little kid playing connect the dots. Just leave it. Okay? So we go in, we write our equation. We ended up going with x squared -3. That's what I went with. You could use whatever you found that was correct. And we're almost done. This is where a lot of people are going to write that. They're going to fill in that last blank and go, hallelujah, done with Mr. Sorrell's test. Okay, we are done with math for the day, yada, yada, yada. But there's one little thing that I like for you to add. And it's a small sentence. And it goes after this equation. And it's some variant of where the domain, which is also known as x values, is only integers. That's what means it can only count like our table can count. It only counts 0, 1, 2, 3, 4. It doesn't count everything between 0 and 1. It doesn't count half or a third or 2/5 or 4/5 or 6/7. It doesn't count all those little itty bitty points in between. It doesn't count all those crazy infinite decimals in there. It literally skips and hops. Skips from 0, which was down here, straight to 1, straight to 2, and straight to 3. That's what makes it discrete. And this sentence, whichever way you kind of like to shorthand it or write it, denotes